In this video, we're going to focus on finding the area of different shapes that you'll encounter in a typical geometry course. The first shape that we need to talk about is the rectangle. Let's say the rectangle has a length of 8 and a width of 5. What is the area of the rectangle? The area is simply length times width. So in this example, it's just 8 times 5, which is 40. Now you may need to keep in mind the units of the area. Let's say this is 8 feet by 5 feet. Then the area is 40 square feet. Now the next shape that we need to talk about is the triangle. Let's start with a right triangle. So let's say if the base of the triangle is 10 and the height is 8, what is the area of the triangle? The area is 1/2 base times height. So we said 10 is the base and the height is 8. So this is going to be 1/2, 10 times 8. Half of 10 is 5, and 5 times 8 is 40. So it's 40 square units. Now what if you have a triangle that looks like this? Let's say this is 9, and this is 5, and this is 6. What's the area of the triangle? So for any right triangle, you can use the same formula. It's 1/2 base times height. In this example, the height is 9, but the length of the base is 5 plus 6. The base of the triangle is this entire length, which is 11. So it's going to be 1/2, 9 times 11. 9 times 11 is 99. And half of 100 is 50, so half of 99 is 49.5. Now what if we have an equilateral triangle? Let's say all sides are 10. What is the area of this triangle? For an equilateral triangle, the equation that you need is the square root of 3 over 4 times s squared. So it's root 3 over 4 times 10 squared. 10 squared, that's 100, and 100 divided by 4 is 25. So it's 25 root 3. That's how you could find the area of an equilateral triangle. Now let's say if we have a square, and the length of the square is 9. What is the area of this figure? Now for a square, all sides are the same. So the length and the width of the square is 9. The area of a square is simply s squared, or side squared. So it's going to be 9 squared, which is just 81. Now let's talk about the area of a circle. So let's say if you're given the diameter of the circle, and let's say the diameter of the circle is 10 centimeters. What is the area of the circle? To find the area, it's equal to pi r squared. The radius, r, is 1/2 of the diameter. So this is the diameter d, and this portion is the radius of the circle. So the radius is half of 10, which is 5. So it's 5 centimeters. So the area is going to be pi times 5 squared, or simply 25 pi square centimeters. Now consider this problem. Let's say we have a circle, and we want to find the area of a sector of the circle. And let's say the angle here is 60. So we want to find the area of this shaded region. And let's say the circle has a radius of 10. What is the area of the green region? Just the sector. To find the area of a portion of a circle, it's going to be the angle in degrees divided by 360. So that's the fraction of the circle times the area of the entire circle, which is pi r squared. So the angle theta is 60. So it's going to be 60 divided by 360 multiplied by pi times the radius squared, which the radius is 10. Now 60 divided by 360, what we can do is cancel a 0. So we have 6 divided by 36. And 10 squared is 100. Now, 36 is basically 6 times 6. So we can get rid of one of the 6 values. So we're left with 100 pi divided by 6. Now we could reduce the fraction. If we divide both numbers by 2, half of 100 is 50, half of 6 is 3. So it's 50 pi divided by 3. So that's the area of the sector. And let's say if you have a semicircle, and let's say the radius of that circle is 8. If you need to find the area of a semicircle, it's 1/2 pi r squared because we have half a circle. So it's 1/2 pi times 8 squared. And 8 squared, that's 64. And half of 64 is 32. So in this example, the area of the semicircle is 32 pi square units. Next up, we have the area of a parallelogram. Let's say if the base is 8 and the height is 12. What's the area of the parallelogram? The area is very similar to a rectangle. It's base times height. So it's 8 times 12. And 8 times 12 is 96. So that's the area of this particular parallelogram. Now let's say if we have another one that looks like this. Let's say if you're given the slant height instead. Let's say the slant height is 5. And this section is 9. But this part, let's say is 3, and this part is 6. What is the area of this parallelogram? In order to find the area, you got to find the height first. And notice that we have a right triangle. The hypotenuse of the right triangle is 5, and one of the legs is 3. So we got to find the missing side. So we could use a squared plus b squared is equal to c squared. So a is 3. We're looking for the missing side b. And hypotenuse c is 5. 3 squared is 9. 5 squared is 25. 25 minus 9 is 16. And the square root of 16 is 4. So the missing side, or the height, is 4. So now we could use the formula area as base times height. We have a base of 9 and a height of 4, so 9 times 4 is 36. Next up, we have the area of a trapezoid. So let's say the first base has a length of 10 and the second one 20. And let's say the height of the trapezoid rather, is 8. Find the area of this trapezoid. The area is 1/2 the sum of the two bases, b1 plus b2, times the height. b1 is 10, and b2, the second base, is 20, and the height is 8. So 10 plus 20 is 30. And half of 8, if we just multiply these two, that's 4. So this becomes 4 times 30, which is 120. So that's the area of this particular trapezoid. Now let me give you another problem that's similar to this one. So let's say that these two sides are 10. And let's say this is 12 and this is 24. Find the area of the trapezoid. In order for us to do that, we need to break it up into parts. So we need to make two right triangles. Now keep in mind, this entire length is 24, which means that this is 12. So this section has to be 6, and that has to be 6, so that it adds up to 24. So now we can find the height of the right triangle. So this is 10, this is 6, we've got to find the missing side. So using the same equation, a squared plus b squared is equal to c squared. Let's say a is 6, b is the height that we're looking for, and c is 10. 6 squared is 36, 10 squared is 100, and 100 minus 36 is 64, and the square root of 64 is 8. So the height is 8. Now that we have the height, we can now find the area. So the area is going to be 1/2 b1, which is 12, plus b2, which is 24, times the height of 8. So 12 plus 24, that's 36. And half of 36 is 18. So 18 times 8. Let's break 18 into 10 and 8 and distribute 8. 8 times 10 is 80. 8 times 8 is 64. And 80 plus 64 is 144. So that's the area of this particular trapezoid. Now the next shape that we need to talk about is the rhombus. So let's say the length of the first diagonal is 10, and the length of the second diagonal is 12. What is the area of this rhombus? By the way, for a rhombus, all sides are congruent like a square, and the diagonals bisect each other at 90 degrees. So those are some things to keep in mind. The area of a diagonal, not a diagonal, but a rhombus, is 1/2 d1 times d2. So it's the product of the two diagonals times 1/2. So it's 1/2 times 10 times 12. Half of 10 is 5. 5 times 12 is 60. So that's the area of this particular rhombus. Now, here's another problem. So let's say the length of one of the sides is 13, and this side is 5, where 5 is only half of one of the diagonals. Find the area of this particular rhombus. So let's focus on the right triangle. This is 5, this is 13. It helps to know the special right triangles. For example, there's a 3, 4, 5 triangle. Also, if you multiply these numbers by 2, you can get the 6, 8, 10 triangle, which we covered. There is the 7, 24, 25 triangle, the 8, 15, 17 right triangle, and also the 5, 12, 13 triangle. So we have two of these numbers, 5 and 13. Therefore, the missing side must be 12. Now that we know what the missing side is, you can also use the Pythagorean theorem to get 12 if you want to. You can use a squared plus b squared equals c squared to get the same answer. But once we have the missing side, we now have the length of the two diagonals. So diagonal 1 is 5 and 5. These two sides are equivalent. So diagonal 1 has a length of 10. Diagonal 2 has a length of 12 plus 12, which is 24. So a is equal to 1/2 d1 d2. So it's 1/2 of 10 times 12. Not 12, but 24. Now, half of 24 is 12. And 12 times 10 is 120. So the area of this particular rhombus is 120 square units. Now, let's say if you have a triangle where you're given two sides and the included angle. What is the area of this particular triangle? The area is 1/2 AB sine C. So let's call this angle A, angle B, angle C. This is side C, side A, and side B. So in this case, A, lowercase a, is 12, and lowercase b, or side B, is 10. And the angle between them, that's angle C, that's 30. Half of 12 is 6, and sine 30 is 1/2. Half of 10 is 5, and 6 times 5 is 30. So that's the area of this particular triangle. So if you have two sides of a triangle, and the included angle, you can use this formula. So this works if you do not have a right triangle. How can we find the area of a scalene triangle? Let's say this is 9, 10, and this is 11. So this is not a right triangle, and we don't have any angles. So what can we do to find the area of a triangle if we're given all three sides? The first thing we need to do is find S, which is 1/2 of the perimeter of the triangle. So it's going to be 9 plus 10 plus 11 divided by 2. 9 plus 10 is 19, 19 plus 11 is 30, and 30 divided by 2 is 15. So that's the value of S. So now that we have the value of S, we can use Heron's formula to find the area. So it's going to be the square root of S times S minus A times S minus B times S minus C. S is 15, and then it's going to be 15 minus 9 times 15 minus 10 times 15 minus 11. 15 minus 9 is 6, 15 minus 10 is 5, 15 minus 11 is 4. Now let's see if we could simplify this an easier way. 15 can be broken into 5 and 3, and 6 is 3 times 2. I'm not going to change the 5, and 4 I'm going to leave it alone. So basically, these two can come out as a single 5. These two can come out as a single 3. And the square root of 4 is 2, so that comes out as a 2. So we're left over with a 2 inside. 5 times 3 is 30. I mean, not 30, but 15. And 15 times 2 is 30. So the final answer is 30 square root 2. So that's the area of the triangle using Heron's formula. Let's say if we have a square and we're given the length of the diagonal. And let's say the length of that diagonal is 10 square root 2. What is the area of the square? Now we know that the area is basically side squared. All sides of the square are congruent. So therefore we could find the side by using the Pythagorean theorem. If this is S, and that's 10 root 2, we can solve it. So using the equation a squared plus b squared is equal to c squared, a and b are both s in this example, and c is 10 root 2. S squared plus s squared is 2s squared. 10 squared is 100, and the square root of 2 squared, which is like the square root of 2 times the square root of 2, that's the square root of 4, which is 2. So we can divide both sides by 2. So therefore s squared is 100, and the square root of 100 is 10. Now the area is s squared, and s squared is 100, so that is the area. So that's the answer, 100. Now let's say if we have a circle, and there's a right triangle in the circle. Let's call this A, B, and C. And C is the center of the circle. And you're given the length of one side of the triangle. Let's say it's 8. Your task is to find the area of the shaded region. To find the area of the shaded region, it's going to be the area of the large object, the object on the outside, which is the area of the circle, minus the area of the object on the inside, which is the area of the triangle. So the area of the shaded region is going to be pi r squared minus 1/2 base times height. Now notice that 8 is the radius of the triangle. The radius is the distance between the center of the circle and any point on a triangle. So AC is also the radius of the circle, which means this section is 8. And that's the base and the height of the triangle. So the radius, which is 8, is the same as the base of the triangle and it's the same as the height of the triangle. So this is going to be 64 pi minus 8 times 8 is 64, and half of 64 is 32. So the area of the shaded region is 64 pi minus 32.